time cannot be 0, but the initial time is just considered as 0. First equation of motion is V is equal to U plus AT. Relative means we just relate one thing with the other thing. Who are our relatives? We relate them with respect to us. Either V square minus U square is equal to 2AS is the equation, or else V square is equal to U square plus 2AS will be the equation. Hello everyone, I am Vrinda, Faculty of Physics from Vidhyaashram School of Excellence, Mysuru, welcoming you all to Chapter 3, Motion in a Straight Line, and it is a session 2. So in today's class, we are dealing with the equations of motion. So there are 3 equations of motion which we have to derive. So before deriving the equation of motion, let us go through this. That is, we have to consider a figure. Usually in this class, that is in the previous session, we had considered about x-axis as well as y-axis. That x-axis and y-axis gives either the position with respect to time graph or else velocity with respect to time graph. So here we consider the velocity with respect to time graph. So suppose a body is said to be moving with uniform velocity from t is equal to 0 to t is equal to t seconds. So here if there is a velocity and this is the time graph from 0 to certain interval of time, that is t seconds, okay, from initial time to final time. Time cannot be 0, but the initial time is just considered as 0. So now here we have, suppose if there is a body or an object which travels from certain initial point, that is when time t is 0, then it reaches with uniform velocity, means the line is said to be increasing as we had studied in the previous session, the graphical representations. So here at time t, suppose that this is the time t, at time t it is in the final position. So this is initial and this is final. Suppose if this line is named as A as well as B, then when you just draw this line to certain time interval and that time interval is called as T, capital letter T, you have OA and B as well as C, okay, OA, B, C. So suppose if you just take a line like this, that is to make a triangle, it can be named as D. So OA means it is a velocity. This is a velocity time graph. This corresponds to velocity, that is y-axis corresponds to velocity, which means to say that at time t, what is the velocity you are having? That is initial velocity. And at time capital letter T, that is the final time, you have final velocity, which you can write it as U, as well as B and C is named as V. Okay, so you have OA said to be U. It's clear over here, and BC, this is the final velocity, so BC is V, and O to C, it is named as time taken, that is the final time which is given capital letter T. This is how exactly you just name the components in the graph. Having this, let us just equate for 3 equations of motion. So which are those 3 equations of motion? Kinematic equations for uniformly accelerated motion from VT graph. By this, we need to know certain terms. That is, we have velocity in the y-axis, time in the x-axis, and there is a certain object which moves from 0th time to certain interval. With the certain interval of time it moves, so it occupies the final velocity here, and the time taken will be given in capital letter T, or it is also called as T. So if this is the origin from O to A, you have initial velocity. From A to B, you have, this is the displacement undertaken by an object, and B to C, you have final velocity. When you just draw a line, what happens? You can just call this as D. This is the hour construction. So now if you want to know the value of BD, what is that you have to do? That is nothing but out of the complete distance, that is V, you're subtracting only U part, because AO is parallel to DC. So you can consider V minus U concept in case of BD. So you know that OA is nothing but U, BC is nothing but V, BD is nothing but V minus U, and OC is nothing but T. So these are the terms or the components you need to know under the graphical representation of the velocity time graph. in a uniformly accelerated motion of a particle. Okay, so now you need to equate for first equation of motion. You need to understand this. You need to read this. V is equal to u plus at. You need to know about this equation. So first equation of motion is V is equal to u plus at. So now in order to equate this, we know that acceleration is equal to change in velocity with respect to time. So what is change in velocity? You can give this as acceleration as A. Change in velocity is final velocity minus initial velocity divided by t. So now you have A with goes with t. So at is equal to V minus u. So you can take this negative and this term other side. So you have V is equal to u plus at plus u plus at. So here you have got this equation, V is equal to u plus at. This is how exactly you go with the equation of motion, wherein we know that A means it is said to be acceleration, and we already know that it has got formula. Acceleration is equal to change in velocity. Change in velocity is nothing but initial minus final velocity with respect to time. This is given over there, and that is equated to give the following equation of motion, where V means final velocity. You can call V means final velocity. U means it is initial velocity. A means it is acceleration. T means it is time taken. So these are the terms for this equation of motion. Next we are going on to the second equation of motion, that is S is equal to ut plus half at square. For this, let us just draw the velocity time graph. This is time and this is velocity, wherein this is y-axis and this is x-axis. So there is a point from here. So whenever we go with the uniform accelerated motion, you will have this such kind of a line. So this is the origin to this initial point is A, and the displacement undertaken by an object is said to be A as well as B. And then you have a line which joins down, that is called as C. So this line is called as initial velocity. This line is called as final velocity. So there is a construction which is done, and that is known as point D. So this point is said to be V minus U. You will get the value for BD. So this value is said to be T. So now we need to find out the complete texture of this, the complete area of this, in order to identify S is equal to ut plus half at square. For that, we know that area of OA, B, D, C, the complete area under this curve is said to be calculated, which is equal to, you have one is triangle, another one is, you have rectangle. Over here you have triangle as well as rectangle. So what is that you have to do? Area of rectangle plus area of triangle, both are there in order to give the area of OABDC. So what is that you do? Area of a rectangle is length into breadth, and area of a triangle is half into base into height. So length into breadth in case of area of triangle, this is considered as length, that is U, and breadth is nothing but T. So length into breadth is, length is U, breadth is T, plus half. Base of this triangle is AD into height of this triangle is BD. Okay, so which is equal to UT plus half. Since AD is parallel to OC, OC value is T, that means to say that OC is equal to AD, which is equal to T. So you have got here T, and BD value is V minus U. So it is V minus U. On equating UT plus half, this V minus U becomes the acceleration, because you know that acceleration is equal to velocity, change in velocity with respect to time. So v minus u becomes at. Okay, so what is v minus u? It is t into at, so it is at square. So s is equal to ut plus half at square is the equation which is proved by this. So with the help of this diagrammatic representation and this area, considering the area of rectangle as well as triangle, you can equate for the second equation of motion. So now we have the third equation of motion for us to derive, that is v square is equal to u square plus 2as. This is also one of the main, that is all three equations of motions are very important. So how do you get this equation of motion? For this equation to be derived, we will have to consider the same representation, that is y-axis and this is x-axis. So this is time corresponding to time and here y-axis corresponds to the velocity. So there is a displacement of an object from point A to B. So this O to A is said to be U and B to C is said to be V. So construction is given over here and this is D. B to D is said to be V minus U and this is T. So this will also be T. This is U and this is U. This is V minus U is the consideration here. So this is nothing but the trapezium which is given over here. So on the whole we consider it as a trapezium. Either we can break into two pieces like the previous equation and do, or else it can be even considered in case of a trapezium. So area of a trapezium OABCD, area of a trapezium is given as half into sum of parallel sides it is, multiplied with the height. So this is the equation. So let us go with this. Area of OABDC is equal to half into sum of, let us just divide this, sum of parallel sides. So which are those parallel sides? We consider it as OA and BC. So OA and BC are the parallel sides into the height. If these two are the parallel sides, the height goes with OC into OC. So how can you equate? OA means U, BC means it is V, into the height OC means it is T, divided by 2. Okay, and we know that T is equal to, that is A is equal to V minus U divided by T. So T is equal to V minus U divided by A. So which is equal to U plus V, and we have V minus U divided by 2 and A, which is equal to U into V is UV plus U into U is U square, plus into minus is minus U square, plus into plus is plus V square, plus into minus is minus UV. Minus UV plus UV cancels, divided by 2A, and here you are considering area so that you can consider it as S. So here when this 2A goes with S, you have 2AS is equal to minus U square plus V square. So if you are taking the negative towards the other side, V square is equal to U square plus 2AS is the equation what you have to know, and this is the same equation. Either V square minus U square is equal to 2AS is the equation, or else V square is equal to U square plus 2AS will be the equation. So this S is a displacement, A is the acceleration, V means the final velocity, and U means the initial velocity. So these are the things for you to understand in order to derive this equation. So next we have got motion under gravity. What is meant by gravity? Whenever you see an object, whenever you throw an object upwards in the upward direction, what happens in this planet? That is, in each and every planet, there is certain gravitational force, which means to say that it is a pull towards the earth. Okay, it's a gravity. That means to say each and every planet has got its own gravitational effect. Okay. So now, this gravitational force corresponds to the weight of a human and not the mass. Mass is the complete molecule or the matter which is present within an object, okay? But weight means mass with respect to acceleration due to gravity. Each object is having certain mass. If the mass acts with respect to the gravitational force, only then we can say that the body is having certain amount of weight, okay, and the weight differs from one place to the other place. So here we are checking onto the gravitational force. That means to say that it is a pull towards the earth, and it is considered to be one of the fundamental forces in nature, which is said to be the weakest force in nature. So for that, you can see whatever object you throw up, every object comes down due to its mass as well as acceleration due to gravity. So here you have motion under gravity, that is when a body falls vertically downwards, there is a change in its velocity. Again, the change in velocity is due to the pressure of the air which is present over there, which lines the falling body. Okay, due to that pressure, okay, due to the atmospheric layers or due to the atmosphere and the pressure which is present in the air or the atmosphere, is because of that we have change in velocity and we experience certain type of acceleration, because of which the objects doesn't fall at particular instant or particular interval of time. Okay, so now acceleration is due to gravitational force, therefore it is termed as acceleration due to gravity, which is given by small letter g, and it is represented by g, which is given over here. Okay, so what is exactly the value of g is our question. So I'll come to that. So it is value of g is high at poles. You can see there is a pole here and there is an equator here. Okay, so weight is minimum at the equator and weight is maximum at the poles, and that is why, because the value of gravitational force is higher at the poles and the value of gravity is lower at the equator. So for freely falling body, gravitational force is always positive, because if a body falls downwards, always the acceleration due to gravity is acting downwards. So for the freely falling body, the acceleration due to gravity is positive. Suppose if the acceleration is toward upwards, that is for the object which is being thrown upwards, for that it is negative, because it is against the acceleration due to gravity. So at the poles you have a value of g is high at the poles, and the value is said to be 9.83 meter per second square. Meter per second square is the SI unit of acceleration, and you have acceleration due to gravity which is lower at the equator, which is equal to 9.72 meter per second square. So on the whole, they have taken the round figure of this and this, that is they have given together as the acceleration due to gravity in the complete earth is said to be 9.8 meter per second square. So this is the value for acceleration due to gravity what we consider, for which I had placed a question mark here. That is the value of acceleration due to gravity. These are all the things you need to know about the gravity, motion under gravity. Okay, so the same concept about the gravity is studied in the same class in the upcoming chapter. And next you have the relative velocity, which means to say that it is the last concept of this chapter known as relative velocity. Here, velocity of one object with respect to the other we are studying. Relative means we just relate one thing with the other thing. Who are our relatives? We relate them with respect to us. He is my brother, she is my sister, he is my uncle and she is my aunt. This is how exactly you give the relation. Why do you mention he is my? He and my, both the things you operate over there. That means to say that you relate two things. You are relating two persons over there, you with respect to others. This is how exactly it goes. Relative velocity. That means the two velocities are related with each other. So you can see over here, ball which is placed with respect to this train, the train as well as ball. So here we just consider the velocity of the ball, we subtract it with respect to train, or we subtract the velocity of train with respect to ground. So one with the other. Usually the object A is related with respect to B. So this is how exactly the relative velocity of two objects you give. You just take the difference between two velocities of two objects and then you just give the relative velocity of one with respect to other. That is how you go on with relative velocity. Okay. In today's class, we have just dealt with the equations of motions. The terms in order to derive those equations of motion was very much necessary. In two of the slides, we studied the terms to know, and then we further went with the equations of motion. So we studied about 3 equations of motion and how to derive it. We are also having different ways of deriving, and it is the simplest one and easiest one which you have to focus over. And then you have the motion under gravity, where exactly you consider the gravitational pull or the gravitational force, for which what is the value at poles you had studied, what is the value at the equator, and how do you equate it, that is how do you give a standard form of the acceleration due to gravity and what is its denotation, how is it denoted, that is what you had studied, as well as the relative velocity. So let us all meet in the next class with a new chapter, with a new session. Until then, have a good day. Thank you.